Okay, so here's a quick lesson on 15.3, Physical Science 20, laws of refraction. So let's take a look at this. We can predict with accuracy how a light ray bounces off a mirror. We've already worked with that, right? This is thanks to the law of reflection. And that is the angle of incidence equals the angle of reflection. So we know this to be true. That's a law of reflection. It turns out that the amount that light bends when it hits the surface of a new medium can also be predicted, thanks to the careful work of Willebrod Snell. Now you can think about naming your firstborn son Willebrod Snell if you want. It's probably a pretty cool name. Anyway, so just like reflection has predictable rules and laws, also refraction, so the bending of light, is also very predictable. So he discovered the mathematical relationship between the angle of incidence and the angle of refraction. And we call it now Snell's law. Okay? So here it is down here. I've already got that highlighted for you. It says this, the sine and SIN. Sorry, there you go. The sine, SIN is the sine, so that is the trigonometric ratio. Okay, on your calculator there, you'll see the sine button, right? So that's the sine of I, and I is the angle of incidence. So I is the angle of incidence, divided by the sine of R, that's the angle of refraction here, equals N. And that is what we already discussed in your previous lesson here, the index of refraction. Okay? So that's very important. That's very important. And the important thing to remember with this too is that the incident ray, and you might have to just make this as a separate note here because it's not in your printed notes, but the incident ray is in air. Okay? So that's important. So the incident ray that's coming to the surface of the new medium is coming out of air always. And if it's not air, we're going to deal with that in another section, and we're going to add to this equation if it's not air. The refracted ray is in another medium. Okay? So it's in another medium. It's not air. It's something different. In order for it to refract, it's going to be something different, whether it's water or going into glass or something like that. Okay, so written in words, this is what it looks like here, okay? The laws of refraction in words now. And that's going to be this. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. And that constant is equal to the index of refraction. So that's what this equation says, this formula kind of says. That's what it is in words. So the sine of angle I divided by sine of angle R equals N. Now, coming from that, if that's true, right, we can find the angle of incidence or the angle of refraction by rearranging this formula. And so what you also want to know is this, is that the sine of I also equals N times the sine of R. And if you take the second function of sine here, so sine to the -1 of both sides, and I'll show you how to do this in a second, you get the actual angle of incidence of N times sine R. And so then, of course, also, you could write this down, sine of R equals sine of I divided by N. And so R equals the inverse of sine, or the second function sine, of sine of I over N. Now that may be a little bit, that's a lot of math there and some funny symbols, but I'll show you kind of how that works here soon, okay? So you might want to just jot that down. So this is the bottom line here. I equals the second function of sine of N times sine R. And then the angle of refraction is second function sine of sine I over N. Okay, so let's say we have an example of a light ray coming in. Here's our angle of incidence. I'm going to draw this the best I can freehand here. So now, is angle of incidence measured from the horizontal or from the vertical? Okay. And we have an angle of refraction. So this is in air, obviously, right? This top one is air. And let's say this bottom one, we're going into water. Okay? Let's say we're gonna do water here, right? Okay. So here's water. So this angle of incidence, this index of refraction is 1.33, right? So is this light ray, is this angle of incidence, is it going to bend towards the normal or away from the normal? Away? So you think it's going to go like this? Like that? Now, okay, why did you guess that? Can you tell me why? Just a guess. Okay. Well, you're actually not quite correct. Okay? So what you have to remember is this, is if the index of refraction is greater than 1, okay, so because air is pretty much 1, right? If the index of refraction is larger, that means the light ray is going to slow down. That means it's going to bend towards the normal. Okay? So in this case, if we go into water or flint glass or diamond, or anything like that, it's going to actually bend towards the normal. Bad line there. It's going to bend towards the normal, and the angle of refraction is going to be slightly smaller. Okay, so I is going to be this big, and R, okay, is going to be smaller. Okay, so that's the first thing you want to make sure you understand. Now, let's say that the angle of incidence here is, I don't know, let's say it's 42 degrees. And we want to find the angle of refraction. We don't know what that is. But we know that the n of the second medium is 1.33. So now that we know that, we can use Snell's law, because Snell's law says that sine of I over sine of R equals n, right? And so we can solve for R. So in the previous page there, I kind of showed you how we can rearrange this. And so you multiply both sides by R. Okay, this is sort of how you work it out. You divide by n. So sine of R equals sine of I over n. And then we take the inverse of sine here, on both sides. And so it looks like this, right? This is what we just did. Sine to the negative 1 of sine of I over n equals R. You see that? Okay, so I'm going to erase the work here to get that. So now that we have this, let's fill in our values and put it in the calculator. Okay, let's move that over here. And so sine of I, that's going to be sine of 42 degrees, right? N is going to be 1.33 because we're going into water. And so if we look at this on our calculator, your calculator might look a little bit different than mine. Let's clear this away. So sine to the negative 1, that's not really, that shouldn't be that scary. It's second function sine, that's all it is. Okay? So you want to do the inverse of sine, and then inside there you want to go regular sine of 42, close that bracket, divided by 1.33, close that bracket. Now you do have to make sure that you are in degree measure here. So your calculator might be in radian, depending on whether classes you're taking or whatever, but it has to be dealing with degrees, okay? So if we do that and we hit enter, then we get this for an answer. And look at that. That actually is our angle of refraction. Okay? So again, just take a look at that, and I'll just clip that and make it a permanent part of our notes here. So the calculator screen looks like this. And so therefore we understand that the angle of refraction, and it should be lower than 42, right? That's what we hypothesized. That's what we guessed. So angle is 30.2 degrees, angle of refraction. So that's one way we can use this Snell's law, okay, to solve for parts of the equation. And of course, if I'm given I and given R, I can solve for n, right? And so on. Okay, so that's the notes and an example there of using Snell's law. Any questions? Okay. So there's your assignment from your text then on this one. So you have that in your notes there.